If we imagine a future where humanity will spend a significant level of its activities in outer space, that means that you want to construct humans that are resilient to those harsh conditions in space, and that means different biological structure, in the sense that right now we are vulnerable to cosmic rays, and it will be really difficult to protect the human body for, and also with a lifespan of 100 years, you can't travel very far. And if you want to reach the nearest star, even light takes 4.25 years to get to Proxima Centauri. So you would need to develop a new form of the human body that is resilient to interstellar travel, and so lives very long, can stay dormant for millions of years and somehow survive that. And the reason I'm bringing this up is, if we can imagine a way of doing that, we don't need to develop very fast propulsion near the speed of light. We can just use what we know, and if it's possible, then we can imagine better what other civilizations that had the same ambitions might have been up to. And so what's your take on allowing humans to travel for millions of years through space?
Right. So I think at this point, the conversation bifurcates where we have, if we really want, so humans, we are going to be pragmatic, and some of the solutions will be physics and chemistry rather than biology. So, for example, radiation and microgravity are quite threatening. Um, I don't think any human has lived in space long enough for microgravity to have serious consequences, but those that have pushed the limit past a year have suffered from it. And going back to Earth doesn't fix all the bone rearrangements and circulatory changes and so forth. So, but both of those have physics solutions, right? So you can put us in a massive container, something
Shield.
that's equivalent to about 10 meters of water, which isn't
Mhm.
that bad, or equivalent, even thinner if you're using metals. And then some kind of
Spin it.
magnetic radiation belt. So if you put those, but that makes the payload now much bigger. And so sending that at any reasonable rate becomes harder. And the same thing for microgravity. If you spin, which is something that's in all the science fiction books, but is in none of the NASA missions that I know of, because I guess it's a little bit harder than some of the things we've done before. But anyway, those are two physics solutions for our two biggest problems. But now you've got, and you probably, sometimes people talk about freezing humans, to make the long journeys. The problem with freezing is the radiation isn't frozen. So even if you got radiation down to where it is on Earth, which is pretty challenging to do without a gigantic Earth to provide atmosphere and radiation, magnetic.
Magnetic. Yeah.
Anyway, if you could shrink that down a little bit, freezing is not a solution because you need the active repair processes. Now, you might be able to get away with a little bit less, like you thaw them every 10 years or something like that and let it do radiation damage. Maybe we know how to make things more radiation resistant than humans are. So, for example, we have naturally occurring bacteria, but more importantly, we have
Tardigrades.
tardigrade, yeah, as a invertebrate, which can tolerate hundreds of times more. But more importantly, we have engineered a bacterium to be more resistant by about 100,000-fold. So getting up into the range of the maximum evolutionarily, you can do it with just a handful of mutations. So that bodes.
But can it bring the lifespan to millions of years? That's my question.
Well, that's a bacterium, and so it has no lifespan to speak of. Lifespan is an artifact of multicellularity mostly, although in principle, some people think unicellulars can have
Yeah.
lifespan.
So, but do you think that it would be possible for humans to travel interstellar or not?
I do. Oh, I do. I just think that it's the bifurcation I was talking about is one is we provide something where people can be awake, or at least metabolically awake, and if they're totally functionally awake, so that then they need a social structure, which means you need a lot of humans. And so you start getting a bigger and bigger ship. The other direction is to shrink humans into smaller and smaller pieces, which, as you know, I've published a paper on this topic, where we might, as speculatively, might get down into the nanogram or picogram range, which has the additional advantage that they have a smaller cross-section and they can go much faster,
Right.
possibly, a fraction of the speed of light.